Hello, everyone. In today's discussion, we'll talk about how we can enhance the in-store shopping with serverless components in AWS. And that way, we're creating an endless aisle architecture, all powered by cloud, in this case, AWS. All right, let's first understand what endless aisle concept is. Well, in a traditional shopping, the store keeps products in stock in their own warehouse and they sell directly to customers, right? But many small retailers, right, they don't have space or budget to store lots of those extra products. So this endless aisle is a smart solution by way that if a product is not available in the store, for example, let's say a t-shirt in your color or size is not available, you can simply order it on a tablet or a kiosk and it will be shipped directly to your home from a partner warehouse. Amazing, isn't it? This is way much different from doing online shopping from home. Now here you can feel the texture of the fabric, you can see how it looks on you and be impressed with it, and on and on. So this is also called as drop shipping. So the store doesn't keep the product, but the partner company out there, it actually delivers to you. And you can imagine, right, how it is way different from online shop. So the definition is endless aisle actually allows customers to order products that are actually not available in the store, but it's available somewhere in the warehouse, in the partner's warehouse, and the store has very much access to it. In other words, it's available in an extended inventory through digital means. And the benefit for the store is it reduces the need for extensive in-store inventory for that store, and it increases the product availability and customer satisfaction. So you go to a shop and you like a product, and you're not going to return disappointed because the size and the color is not available in the store. You are going to return after making a purchase, right? Instead of just picking the product and walking home, it'll get delivered to your home in a day or two. That's the difference. You still walk out with a great amount of satisfaction. So before we talk about the endless aisle model, let's talk about the challenges in the traditional retail model. The limited shelf space there in the shop, right? It actually restricts the product's variety. And sometimes overstocking the product in a shop, it leads to increased cost, right? The cost of buying and getting in vast space to keep all those products, right? And when you don't have the product, right, we actually lose the opportunity to sell something to the customer who come to us. So there are some challenges in this traditional retail model. Let's talk about a solution to this model leveraging AWS Endless Aisle. So the approach is we utilize an AWS serverless service that will help us create a scalable and cost-effective endless aisle system. We'll talk about that in the upcoming slides. And the key component here is there's a front-end application and then there is a back-end service. The front-end application is for product browsing and the back-end service is for order processing and partner integration. Again, we will look at it when we go through this session. All right, and this is how it's going to work. Let's pick this example. So a customer seeks an specific or comes to buy a specific auto shirt in a store. I've picked this auto brand because that's made in India and that's something I like. All right. So a customer seeks a specific auto shirt in a store, and to the disappointment, temporarily, the item is not available in the desired size and desired color. All right. So the store associate identifies or realizes that what the customer wants is not available in the store. So they use a tablet or any other interface of that sort to access the extended inventory of the store, just like what we discussed some time back. And then the customer browses through the color and size and finds a one that's very much appropriate for them. And then they place the order. The order gets shipped to the customer's house. Let's now talk about the different services, Amazon services used in this architecture, right? So let me expand this, right? So here we're using Amazon S3. That's our static website. Now this is the architecture I was referring to. We're going to talk about all these in a moment. Yeah. So here is S3 where all our website files are stored. It's really our website. All right, it gets stored here, and there is CloudFront, which kind of caches the request, which kind of caches the content of the S3 file and then serves it to the customer. And there is Amazon Cognito. It kind of authenticates the user who's trying to log in. And then there is WAF, which is an web application firewall, which is in firewall, which protects the website and the infrastructure from different kinds of attacks. All right. And then there is API gateway. So the front end talks to the back end, the Lambda service and couple of other services behind it. They're exposed to the application through the API gateway. And then there's another authentication system here using Cognito. We'll talk about that later. And there are Lambda services available here. We'll talk about that. And the ones in blue are the databases, the different databases for different use cases or for different actions. We'll talk about that, right? So this is an plain view of or the different components in our architecture. So I showed you S3, which is used to host static website content, and then I showed you CloudFront, which delivers content with low latency, and then we saw Lambda there, which actually executes the backend logic without we getting to manage the servers, and then we saw API gateway, which manages the API requests between the front end and the back end. We saw that. And then there is DynamoDB, which actually stores data about the partner and the order information. And then there is SQS and SES. There is SQS, which is nothing but a queue. We'll talk about that in a minute, right? A full use case of why it's present here. And then there is SES. It's not mentioned here, but it's an email notification system. It is used to send back and forth emails, not back and forth emails, email notifications to the store associate email notification to the customer. And then there is Event Bridge, which actually integrates with external systems, right? Kind of coordinator, I would say, right? Event Bridge, which kind of interacts or integrates everything that's happening or updates everything that's happening to the ERP application and then backwards. And then there is Cognito, which manages the user authentication. When the user wants to log into the app, it's Cognito that allows the user to log in and access the underlying environment behind it. Now let's understand the architecture in detail. Look at this one. Let's say you walk into a clothing store and the shirt you want is not available in your size. And now the store worker kind of gets into action. The store worker scans the shirt barcode that you want using a tablet, and the app that they used kind of checks if the partner company has the item. And if yes, if the response was positive, then those items are shown to you and you can place the order right there. And the item is shipped to your home directly from the partner. All right, so that's how it works. Now, here's how AWS services are used to build this system, also called, the architecture used here to build this system. Like I said, there are two components, right? The front end and the back end. The front end is the website. So the online shopping page, right? The page we see on the app, that's actually stored in S3. And the CloudFront here is used to speed up the website. And WAF, it actually protects the site from all sort of attacks. And Cognitors here, the Cognito, it handles all user level logins very securely. All right. So let's understand the flow here. Now, the store worker logs into the application and he or she scans the barcode. The front end application there sends a request to AWS to get the item, right? It sends the request to AWS to get the item and it passes through API gateway and hits the AWS Lambda called the get item Lambda. So the Lambda function handles the request, and it first checks the DynamoDB for all partner information right here, right? It checks with the DynamoDB to get a list of partner information and how the partner would like to receive an API request. Let's say we work with 10 different partners. 10 different partners would receive or would want to receive those API requests in different fashions, right? So it kind of takes a list and then identifies in which pattern they want to receive that request. And then it receives that details, and there is another Lambda function here which kind of transforms that request into a pattern in which the partner here would accept. If we don't send it the right way, it's going to fail, right? It's not going to, the transaction is not going to get completed. It's not going to get a response that you want, right? So it kind of formats that data, right, or transforms the data into a pattern in which the partner would accept. So now, after that, the partner returns back that response with informations like the product options, the size, the color, and other details, right? So now it replies to that request, and that goes back to the front end. The customer selects and places the order. They finish the order, right? Now the finished order detail, right? The finished order detail passes all the way through and comes to SQS. It's a queue. We'll talk about that in a moment. It's a queue. So that detail is placed in the queue, and the system underneath it, right, create order, right? So it kind of showed what's available. Customer placed the order, but the partner has not received the order yet, right? Only the payment transaction is successful. The order has not been actually placed to the customer yet. All right. So the SQS receives the order and it kind of keeps that message. And here, the Lambda function, it kind of polls SQS and gets that detail. Right. So this system reads the queue and processes the order through this new Lambda. And now the order is sent to the partner for shipping. The partner receives the order, and this is when the order is confirmed. Once confirmed, the details are actually stored in the DynamoDB table, right? And this DynamoDB table is slightly different from the other one because it has streaming enabled, which means any new data entered to it, right, would create an event, right? Only this one, this type of table, in other words, the use case of the table requires streaming, right? So a new data is present. Now that creates a trigger, that creates a trigger, and it kind of notifies this Lambda, which is the notifier system, right? Now the order is complete. This Lambda gets that detail, and this Lambda now says that the order is complete. Let me interact with SES and send an email notification to the store associate, and if another email is attached to it like the customer's email, it would send notification to the customer's email as well. All right, and one final step, there is one data sync Lambda here that you see, right? So this data sync Lambda now updates the customer's ERP application, right? This is the one that kind of keeps track of orders, inventory, how many sales happen, and all that, all right? So this is a high level overview of how an endless aisle serverless partner integration architecture like this one will help retail customers or retail shops, a dress shop in this case, and it'll help them having an endless virtual shelf and help customers in a better way. So this architecture helps small and medium stores avoid stocking every product. They don't have to really stock every product. And it gives customers more buying options. A customer walks in and they have access to like 20 times, 30 times more products than what they see in the store. And it uses cloud service. That way it manages all the IT infrastructure in a smooth fashion. So when we build a system like this, we save a lot of time, we save space, and we also save money while keeping we're doing all that and while keeping our customers happy. Now that we understood the system, let's talk about how the system is applied in real world. Let's say you're in a clothing store and you find a nice auto brand shirt and you want to buy it, but it's not available in your size on the shelf. So the store associate opens their app and scans the shirt barcode, and let's see what happens behind the scenes. So he scans the barcode, the store associate logs into the app using their username and password, and then he scans the barcode on the auto shirt that you have picked, and this is when the system really kicks off in the background, right? So the app reads the barcode and changes it to the product number. Then it calls something called as get item API to find more details. So from the app, a request goes to get item API. Let's pause here for a minute, yeah, and understand how this function works. So this API runs using AWS Lambda, and like I would have mentioned, Lambda is a service you can run code without managing the servers, right? And another advantage is that it only runs when needed, and you only pay for the time you run it. So there's a lot of cost saving there, right? So that's done. And then the get item API triggers the get item Lambda function here. It's like a smart worker that takes the product number and starts the real world and starts the real work, right? So this system is designed in a smart way so it can work with multiple suppliers or partners and not just auto. So we're keeping each partner's connection flexible and separate. So the next step is, so the get item function now goes to the database, that's the DynamoDB right here, and it looks up who the partner info is for the ODD shirt. Now, the DynamoDB, let's talk about DynamoDB. It's a fast and scalable NoSQL database service. It stores data in table and works really well for real-time applications like this one. So it finds Otto's info and sees how to talk with their systems. Next, it uses another Lambda function to change the request info to a format that the auto systems understand. So the transformer function here that kicks in. And then the formatted request is now sent to Auto's partner API, right? It goes in here. It's the partner API. And now Auto responds back with shirt details like the available sizes, the color, the product image, and sometimes even similar shirts you might like. So this actually helps the store to sell more, and it helps the customer as well. The customer can find what they really want, right, with a lot of those options. So that's then shown back to you in the application, and we choose a medium sized auto shirt in black, let's say, and it's now added to the cart. Now you're ready to check out. You enter your address and the payment details and then click submit, and an order here gets placed. Order is gets placed in the application level. All right. So that again gets passed through the Amazon API gateway. All right. So here is the Lambda function that actually creates the order. All right. So you've just initiated creating an order. You have not placed the order. So it goes in here, and there's an SQS in between. I'll explain that in a minute. Right. So when the order is placed, the app sends the details into a queue right here called the create order queue, and that queue is using Amazon SQS. And want to know about Amazon SQS? Amazon SQS is a fully managed messaging queue system. It is actually used to decouple parts of our application, and it makes sure that no data is lost, even if there is a delay for any reason, right? The data won't be lost because the data is present and preserved there in SQS. The data can stay up for like days to sometimes weeks, right? So the data, the order is not lost and it's present all the time. All right, so it's there in the queue, and the create order lambda kicks in, all right, and it picks up the message from the SQS queue and starts processing it. Then number 8, again, the partners kind of expect to receive API calls and data in a certain fashion, certain format to actually place the order, to actually receive the order and send or ship the item to the customer. So there's a create order lambda, and it actually calls another lambda function called the transformation function for creating the order. So it formats the order based on the details again present in the partner table, and then it places the order. Once the order is placed, right? Number 9, once the order is placed, the details are registered. The details are registered in the table. Again, it's a DynamoDB table, and this one is backed up with DynamoDB streams. So DynamoDB streams is like real-time monitoring a table for a new entry and then creating an event based on the new entry. So in this case, there's an entry in the table and it's a new order placed. So that data is present. A new event gets triggered. That event actually triggers an notifier saying that somebody has placed the order, or the order that you have placed is successful. The partner has accepted it and now it's ready for shipment. So it sends a notification to the application owner here or the store associate, and if another email address is added, it will also send notification to that customer as well. And finally, so this all happened in the application itself, right? The store will have an ERP system, ERP application that also needs to be updated. So this application includes something called as Event Bridge. That's another service in AWS that kind of decouples the IT infrastructure and creates communication through events. So the details are not lost. So it saves it kind of creates a sync, creates a lambda sync or data sync job and updates the details to the customer's ERP system. And that's the full story, from scanning your auto shirt to placing an order and getting emails. And this is how the power of smart serverless retail system is. And this is how cloud powers a smart serverless retail system. And I believe this made things clear for you. Right, some of the advantages of the system is, and there's even bridge, it updates the ERP system. The advantage of the system is it's very much scalable. It can automatically handle varying loads. All the components you saw, the DynamoDB, the API gateway, the Lambda, they all can SQS, SES, they all are scalable systems. And it's cost effective as well because we only pay for the resource that we use. And we've reduced the maintenance of this infrastructure because there's no server here that we're managing, and it supports quick deployment. It's quick to implement and update features when and where we want. So let's conclude. So this serverless architecture we looked at, right? It's scalable, cost effective, and it's very apt for a modern retail store. It kind of addresses all the challenges that a retail store has. And we're using AWS here. AWS provides, we saw that, provides a suite of services to implement an endless aisle system very efficiently. We saw that.